Hey guys, this is Weezer, and I'm going to finish the lesson that was on zero exponents. The reason they're separate is that 7th grade standards do not include negative exponents, but 8th grade standards, and you guys are in GT class, and we have to do 8th grade standards, they do include negative exponents. And to be perfectly honest with you, it is very hard to find zero exponents without them being mixed in with negative exponents. That's why you didn't have practice problems, but you'll get enough. Believe me, stay with me. It's a little confusing at first, but after a while, you just start you just have to practice. The more you practice, you just don't even think about it. All right, you ready to go? Get pencil and paper, and please, 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 please. I'll put this in the slide that hopefully you're looking at. So maybe you'll have a place to go and look for it written, but you need to write this down too, because sometimes writing it down sticks in your brain. Whoops. Okay, so this is a review that anything to the 0 power is 1. So I showed you this yesterday. So 10 to the 4th power is 4 zeros. That's 3 zeros, 2 zeros, 1 zero, and then 1. So that was one of my examples as to why a base to a 0 power is 1. Excuse me. But I was looking at my, you may want to look at this too. It doesn't matter. There's the Fort Bend Tutoring, and he has one on integer exponents. And I was just looking to see, how he taught this. And I saw this, and it makes perfect sense. He does sometimes, So that's why I like Fort Bend Tutoring. He says to think of everything in the entire world is multiplied by 1 because of the identity property of multiplication. Anything times 1 is itself. We just don't have to write things like that. I mean, we just know that. So why would we write like everything, every number has a decimal behind it? Well, when we are writing the number 2, we don't put 2 and then a decimal, only if we're numbering our papers or something like that. So just know that anything times 1 is itself. So 1 times Wiesner is Wiesner. What a wonderful thing that is. Just kidding. So if you think about it this way, 5 to the 4th power is, 5 times itself 4 times. But there's also a 1 there. So it's 1 times 5 times itself 4 times. So 5 to the 3rd power is 1 times 5 to the 3rd power. We just don't write the 1. We don't have to. But it's there, and it's good for purposes like this. 5 to the 2nd power is 1 times 5 squared. 5 to the 1st power is just 1 times 5. So then 5 to the 0 power is 1 times no 5s. Okay? So that's just another way for you to hopefully get that anything to the 0 power is 1. Or if you're like me when I was in school, just tell me. I don't care about why. But my niece was totally opposite. She said, why? I taught her Algebra 1. And then I'm teaching something like this, and I'm like, please don't. I hope nobody asks me why. And next thing I know, her hand is, well, why does that work? I'm like, oh. She wasn't trying to be annoying. She just really wanted to know why things work, which is probably why she's doing so well. Dean's List, freshman year, first semester at University of South Carolina. Besides the school, I'm just kidding. She's pretty smart, but yeah, she's got on my nerves. But sometimes people just want to know what it is. Okay, so this is my sloppy attempt to prove what we're going to be learning today, which is still part of that 8th grade standard we've been working on forever. It's why the negative exponents work. And we might jump back to this later, but you can see 10 to the 4th is 10 times itself 4 times, and 2 times 10 to the first power is 10, 10 to the 0 power is 1. Well, then 10 to the negative first power, what? You can have negatives in your exponents? Yep, that's 1 over 10. Because you see, this was multiplication up here at the top. Why my pointers? This is multiplication. So when you start getting into the division, the negatives, that's division. Remember that the negative, I saw this on a video too, the negative means to negate or to do the opposite or the inverse. So what is the inverse of multiplication? Division. Good way to put it. Okay, and then this other side, if you probably were wondering why when we had, daggone, when we had the quotient rule and you had the same base and you were allowed to subtract your exponents, notice that every single time you subtracted your exponents, they all came out positive. Well, that doesn't always happen. And in this case, I have 3 minus 5. Well, 3 minus 5 is negative 2. So that's why we have this whole thing with negative exponents. But if we wrote it out, x to the third power, x times x times x, over x times x times x times x times x, and we marked off all the x's that are in common, I'm left with 1 on the top, the number 1, and then x times x on the bottom, which is x squared. All right, now to the nitty-gritty. When you see definitions when you're in algebra, you're going to see constraints or conditions. And they used to get on my nerves. I'm like, I don't care. Why are you telling me this? But it really makes a difference. And I just want you to be aware of it in case you see it and not make too much out of it. But understand that there is a purpose for it. The conditions to this is that my definition that I'm using is that we know that A is a non-zero integer and N is a positive integer. Now, you want to know why the base cannot be 0? Because 0 to any power is undefined. I bet if you tried it on your calculator, I don't know what would come up because I don't have a graphing calculator with me. But if you tried it, let me know. 0 to the 0 power is undefined. That means it doesn't exist. So here's our definition. The expression a to the negative n is the multiplicative inverse. There's your word there. Multiplicative inverse just means reciprocal. Multiplicative inverses means if you take a fraction, you flip it upside down, and if you multiply them together, they give you 1. So anyway, it's just the reciprocal of a to n, but it's positive now. So a to the negative n is equal to 1 over a to the nth power. Another thing Mr. Witt said that I thought was interesting is that we write numbers all the time, like 2 and 3, and we write variables like a. Well, there's a 1 under it. We just don't write it, but we know that there's a 1 under it. So in that situation, a to the negative nth has a 1 under it. Okay, so when you do the reciprocal or the flip, or whatever it is that you call it, that's why this 1 comes up here, and this a to the negative n comes down here, but something drops off. The negative drops off, okay? That negative disappears. Boy, this makes my eyes hurt. And this is why I said this is going to be on that slide. Woo! I chose some good colors here. The negative exponent, because negative means opposite, tells us that the power needs to be moved, power meaning the entire thing, needs to be moved to the opposite location of a fraction, and the exponent is made positive. Now note, this is a kind of a summary of this horrid mess. I could introduce a different color in here if I wanted to, but I'm not going to be that. Y'all have trouble seeing after this. So note, basically, if the exponent's negative in the numerator, it belongs in the denominator position as a positive. If the exponent is negative in the denominator, then it belongs in the numerator as a positive. It's flip-flop, flip-flop, flip-flop. Okay, remember a negative is another thing that means opposite. Seems like everything does. Okay, so there's an example. 3 to the negative second power is the same thing as 1 over 3 squared. Now, they're going to eventually start making you simplify it out if you can. For right now, we're just going to leave it as positive exponents. I want to make sure you get this part right before we worry about this part. Think about it this way. I've heard it this way before too, and it really helps when you have these long problems and you got exponents everywhere with numbers that need to be moved and other numbers that don't. It's just a mess. But if you think about it this way, cross the line and change the sign. So cross the line, the 3 to the negative second, I cross the line and I change the sign to positive. Notice that we don't change the sign of anything else, just the exponent. Okay? And the line here is that fraction bar. But we know something about what that fraction bar is called. The line of a fraction is called the vinculum. Vinculum. So go to a trivia night and hopefully that word comes up and you win. So m to the negative third, across the line, make it positive. So that's crossing the line and changing the sign. So remember, the m to the negative third is over 1, right? Okay, so that's that one. And then another example, 6 over a to the negative fourth. This is where you would have a negative in the denominator. Well, if it's in the denominator, you still got to cross the line and change the sign. Now, we don't have anything in our denominator anymore. We know that there's a 1 there, but do we have to put it? No. Just 6a to the fourth. Confused yet? I bet you are, and don't worry if you are. Let's just do more examples. Remember, practice, 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 practice. Doesn't make, you hear practice makes perfect? No, practice makes better. And more practice makes you more better. That's not a word. It makes you even better. So the first one, x, example is 2 to the negative third. So I'm going to cross the line and change the sign of my exponent. And then I have to have a number in the numerator, so it's a 1. That's it. Box that thing up. Now, the power of exponents. This is letting me know that, just like with the 0 power yesterday, that the negative in here is also being raised to the negative second. So this entire thing is to the second power, negative second power. And that's important because when we cross the line, we take that negative with us. And we're going to change the sign of the exponent only. So there's a 1 there. So cross the line, change the sign. I brought that negative with the 4 because it was in parentheses. Okay, I just wasted a lot of time, made some mistakes, told some stories. I gotta stop coughing. It's allergies. Yeah, it is allergies. So, I have c to the negative fifth. Well, anyway, the whole time I was doing the slide, I wasn't recording, so, oh well. So, you're going to cross the line and change the sign of your exponent. So, we know that a 1 goes there, but we don't have to write it. It's just c to the fifth power. All right, this next one, negative 3 to the fourth power. Well, see, the negative here, if you want to think about it like this, it's negative 1 times. I hate writing over here in the corner because it's so many scratches. I need to get a new iPad, but I need some money. So that's what it is. It's negative 1 times 3 to the negative fourth. But we don't show that 1 because we don't have to. Just think about the invisible Man or whatever that movie is that's coming out that I will never see because I don't see scary movies. So what you're going to do is cross the line with the 3 to the negative fourth. And you're going to change the sign of the exponent. Now, you can't just leave a negative there. It looks really weird. We got to put the 1 there. Even though we know it's there on these, you have to show it. Because it kind of looks really strange just to have a negative floating around in the air. Now, this one in the corner, x to the negative second over y to the negative second, it's no biggie. Just I'm going to cross the line and change the sign. We're just going to take it a step at a time, though. Oh, cross the line, change the sign, 1 step at a time. Poet didn't know it, make a rhyme all the time. Y to the negative 2 is going to go across the line. I'm going to change my sign. And x to the negative 2, cross the line and change the sign. I'm never going to forget that. Cross the line, change the sign. Okay, now this last one here, x to the negative second, y to the third. This is where I was trying to tell you a story, and then glad I wasn't taping it because I messed the story up. X to the negative 2, we've got to take care of that. He is not where he's supposed to be. He is like a student I had last year that never was where he was supposed to be, but he was always where he wasn't supposed to be. That's my story. And I tell him that all the time when I see him because he's never where he's supposed to be. He was in GT class. All right, cross the line. But I'm going to leave the Y where he is because he is where he's supposed to be. He's supposed to be in the numerator. That X to the negative 2, he was all messed up. He belongs here. Okay? You'll get to practice some in a minute. Yes, a hot minute. So go ahead and copy these down and hit pause, work them out, and then come back and we'll go through them together. Okay, on the first one was like the one we had as an example. I'm going to use a different color. I would use white. So you're going to cross the line and change the sign. So it's 1 over 4 to the third power. So number 2 is negative 5. That's parentheses. Okay, so that means that negative goes with it. So I'm going to cross the line and change the negative only on the exponent. Change the sign only on the exponent. So you get 1 over negative 5 to the 5th. Well, never mind. Okay, number 3, you have in parentheses m times n to the negative third, and then down here you have m times n to the negative second. So my exponents are different, doesn't matter. I'm still going to cross the line and change my sign. So m n, I'm moving this one down, is to the third power now, and then this one, m to the n, m times n to the negative 2, is going to be moved up. So this is my new answer. Just flip-flopped it. Kind of like the one example that I gave you. I just changed it up just a little bit. Okay, this last one, number 4, negative p to the fourth power. That negative is negative 1 times p to the fourth. It doesn't matter. It's still in the right position. The only thing that I'm going to be moving is r to the negative fourth. So it's negative p to the fourth over r to the fourth. Remember, cross the line and change the sign of the exponent. All right. Okay, here's another example. See what I'm talking about? It was almost impossible for me to find just plain zero exponent problems. It was always involved with a negative. So anyway, here they go. That's why you didn't have work to do on the zero exponents. That's okay. You still have to do the work from Monday. the 8 problems that went with powers of a quotient. I was bragging about how well y'all were doing, and then went back and looked, and I said, well, it's not even half of you, but you still do a good job. So 2 is going to stay in the numerator. M to the 0 power, well, we know that's 1, right? So I don't need to write it in. We just know it's there. But this n to the negative 4th, it's n to the positive 4th. Cross the line, change the sign. 2 times 1 is just 2. And then this has to go down there. All right, so this next example, this negative 4, he's okay. This one needs to cross the line, and y to the 3rd is okay. Y to the 3rd is always in the right place. Well, not always. So it's negative 4 y to the 3rd, and then cross the line and change the sign. But do we really need to see that that's a to the power of 1? Not really. You could write your answer like this. Just don't answer them. And some of you were still answering them on something we were doing the other day, and that's fine. But with the way I have to give you the problems and give you the boxes to type in, it can be a little confusing. All right, now it's your turn. Try these 2, write them down, and then hit pause, work them out, and then come back and see how you did. Okay, so for number 1, I know I'm going to be crossing the line. Something just tells me that. Negative 3 is okay to be up top. That x to the negative 3 is not. That needs to go to the bottom. I need to make that 3 positive. So I do need to cross the line with that one. And then this y to the 0 power, that's just 1. So that kind of just goes away. So this is your answer. Negative 3 over x to the 3. X to the 3rd, I guess I should say. Now this last one here, negative 3 times k to the negative 1. Well, this is the only thing that is not in the right place. It has to cross the line. Okay, so negative 3 stays on top, and then k, and that negative 1 becomes 1. Remember, we already talked about this. We don't have to write that. It's not wrong if you do. It just looks better if you don't. Okay, this is it. We'll give you some practice problems. Maybe have a Google Meet today. I keep promising you that, but not been feeling good the last couple of days. But still, you can always write me and request one. I worked one-on-one with somebody that was doing a quiz in the regular math class, or a mini quiz maybe it was. Worked one-on-one with her. Just she and I were in the Google Meet. Just us. So peace out until then, and love ya. Mean it. It's from an old disc jockey duo. I think they're here, John Boy and Billy. But anyway, love you, mean it. Dang, my husband just slammed the door.